We're going to take a look at inequalities, specifically linear inequalities, meaning you just have a variable to the first power, so no second powers or third powers or square roots or anything. I hope you have seen this already, but the big difference between equations, where you have an equal sign, and inequalities, where you have a less than, equal to, greater than, or greater than equal to, is the number of solutions. Very typically, equations will just have one solution, whereas inequalities have lots and lots and lots of solutions. Here's what I mean. I made a little number line here, and I picked out just a few numbers. There's nothing super special about these. I picked them basically kind of at random. We're going to take a look at these options one at a time and see which of these red numbers solve those equations or inequalities. So take a look here at the first. I'm looking for all the numbers that are equal to 6. Well, -1 is not equal to 6. 1/2 is not equal to 6. 3.2 is not equal to 6. 6 is, so there's the one solution. 8.4 isn't, and 10 isn't. This is what we mean when we say equations typically have one solution. Only 6 is equal to 6. So that's it. One solution, good to go, right there it is. Our focus here, though, is going to be on these inequalities. So what does it mean to say that a number is less than 6? And when you're looking at inequalities, a less than, you can think of it two ways. It kind of looks like the letter L if you turn it, a little bit sideways. L for less than. You can also remember it as the inequality points at the small number and is open to the big number. The way that I was taught was, imagine it's an alligator. The alligator eats the bigger number. But regardless, now that we've established this is less than, let's take a look at which numbers are less than 6. And what would be a good color for this? How about the blue? So less than 6. Is -1 less than 6? Yes, it is. Is 1/2 less than 6? Yes, it is. Is 3.2 less than 6? Yes, it is. Is 6 less than 6? No, it is not. 6 is equal to 6. It's not smaller than 6. So I'm not going to include 6 in this solution. 8.4 is not less than 6. Neither is 10. Now, even though we skipped a bunch of these other numbers, really, any number that is to the left of 6 is going to end up being a solution to this inequality. So I'm going to put it this way. If I had 6 as my dividing line, that's 6. I don't want to include 6, so I'm going to draw a circle here but leave it empty. All the numbers that are to the left end up being solutions to this inequality. Okay, let's now do the same thing with x less than or equal to 6. I'm going to do this one in green. So which numbers are less than or equal to 6? So this is saying you can be smaller than 6 or you can be 6. So -1 is smaller, 1/2 is smaller, 3.2 is smaller, 6 is equal, so that equal bar underneath counts. 8.4 is bigger and 10 is bigger. So in this case, it's not only that, so 6 is the dividing line, but I want to count the 6 this time. And the way we'll show that is by filling in the circle. So in both cases, 6 is a boundary, but in this case, because of the equal sign, I want to fill in that boundary. So numbers that are equal to 6 or to the left end up being solutions to this inequality. Next up, let's take a look at x greater than 6. I'll do this one in red. So greater than means I need numbers bigger than 6. Is -1 bigger than 6? No. Is 1/2 bigger than 6? No. 3.2? No. Is 6 bigger than 6? No, it is not. 6 is equal to 6. How about 8.4? Yep, 8.4 is bigger than 6, and so is 10. Actually, even though we skipped a bunch of these other numbers, they're all bigger than 6. So once again, 6 is the dividing line. 6 is not included this time, but all the numbers to the right of 6 are included. So lots and lots of solutions, and they're all to the right of where that 6 is. And then lastly, let's take a look here at the greater than equal to in the purple. Is -1 greater than or equal to 6? No, it's less than 6. How about a half? That's also less. 3.2, also less. How about 6? Yes. Because of this equal underneath, 6 is going to count this time. So is 8.4, and so is 10. So this time, the 6 is the boundary, but because of the equal bar underneath, we want to include the 6, so fill in the circle, and all the numbers to the right end up being bigger. Here's what I want you to take away. When we're talking about an equation, something that has an equal sign, there's very typically just one solution, just the 6 in this case. But if we're dealing with inequalities, you typically have lots of solutions that are either to the left of your boundary number or to the right of your boundary number.